Yeah. Okay, so I'll continue. I'm a member of the Java community process in the executive committee. I'm also a member of the Jakarta EE working group, where I'm the PMC for the EE4J projects. And this is all within the Eclipse Foundation. I'm also a NetBeans committer at the Apache Foundation, and I run a local Java user group in Malmö. I'm a Java champion, and I'm an Oracle Groundbreaker ambassador. And usually my talks are on the topics of Jakarta EE or microprofile. And I do have some Jakarta EE stickers here, so if you want to stick around afterwards for questions or something, so please come up and get them. I don't want to fly them back home to Europe. So, but today I'll talk about serverless. I'll just briefly introduce a little bit about serverless and some of the concepts. Then I'll go through some of the offerings out there and do some demos and using Java in the demos then, and just sum up a little bit at the end. So, what is serverless then? First of all, it's a very bad name. And why is it a bad name? Well, there are still servers. It's just that these servers are somebody else's server. So somebody else is taking care of everything, the setup, the infrastructure, the scaling, everything considering the servers. So what it really is it's actually more, it's no server management. It's serverless abstracts away all the underlying infrastructure, so you can focus on the code and the code only. So you can develop your application faster and better and iterate faster than ever before. Serverless is also automatic scaling. So you can serve your users of your applications or functions from 0 to planet scale, if you like, without even thinking about the infrastructure underneath. Because you don't manage your servers yourself, you just write your functions and you let somebody else take care of it. It's also a payment model. So with serverless or cloud functions, you only pay for the time your function is actually running or being executed. So if you compare it to a traditional server where you have some applications running in a web server, for example, you pay for all the time when the web server is just lying around there waiting for requests. But with serverless, you only pay when the code actually runs. And it's event-driven. So there are, serverless allows you to trigger your code from any type of event you can imagine. It could be something happening on an event queue, or it can be an HTTP request, or it can be a timer request. We're actually running some batch jobs with functions, so we just have a timer that kicks these jobs going. It's very open and familiar in the means that there are no new languages created for serverless. There are no serverless programming language. You use the familiar tools and the languages that you're used to use, and most providers let you pick and choose whichever language you want to use. So serverless is also known as Functions as a Service, or FaaS, or even Cloud Functions. And if you look at this typical kind of maturity stack or layers of cloud infrastructure or as a service services, you usually start at the bottom with infrastructure as a service, which is typically like EC2 in Amazon. And if you add some kind of platform services on top of this, you get platform as a service, and this is typically like Google App Engine. And then a layer over that is that you have some container management or containers you can run your applications in. And for this is, for example, Azure Container Service by Microsoft or Oracle App Container Service. And based on stuff in these layers, you kind of build your applications on top of this. And with functions come in between the containers as a service and the application layer in this pyramid. And we kind of only care about the stuff on top here. Because everything else underneath, whether it's containers, it's platform, it's infrastructure, whatever is going on down there, that is somebody else's job. Because we just want to write our functions and our applications that use our functions. So what about architecture then? What are the implications for application architecture when you introduce functions? Well, in serverless, there is a preference for choreography over orchestration. And that means that every component is more aware of its role in the architecture. In choreography, it's more like in the microservice world where you have decentralized, that every service kind of knows it plays in the architecture. Whereas when you think about orchestration, it's more of a central component that kind of manages things. So what's in it for developers for serverless then? First of all, there are no servers, so you don't have to manage these. But also, it's easier. Because as a developer, you can now focus only on the functionality, only about the code that actually drives your business. That you don't have to think so much about the infrastructure and the scaling and everything underneath. You just write your function and deploy it somewhere. It's faster. You can deploy faster because everything is already up there. So you just have to write your stuff. You can then deploy faster, iterate faster, innovate faster. And it's cheaper. So if you want to test out something and just write a function and see what you can use with it, you will only pay for like the milliseconds that you're actually executing the function, and not for an entire infrastructure setup to test this stuff. And it'll also super powerful if you write a function and you suddenly have a lot of traffic on it. It scales automatically. It manages automatically. You don't have to think about, oh, I have to buy some new hardware or something to have my application run on it. So what's in it for business then? It's kind of the same things that applies for developers. The agility lies in that since developers move faster with less dependencies and innovate faster, you can move your application and iterate faster over it. You can innovate faster because since developers can just throw a function up in some cloud environment, you can just test out new ideas very quickly without having to set up an entire server park to do it. And it's also cost reduction, since you only pay for the execution of your functions and not for the idle time. And it also means that you can reduce the operation costs, because when you don't have people managing your servers, you can just have people managing your cloud environments, which is much easier. So what about Java functions then? We all know that Java kind of starts slow. It has a big memory footprint. It's not very well suited for functions. But that is kind of the old thinking, because it's getting better and it's getting faster and it's getting smaller all the time. And still, if you're running like plain Java on a JVM, you probably want to avoid Java functions for the most extreme scalability needs. But that is also kind of changing, because we have this technology called GraalVM that solves a lot of this stuff. And GraalVM compiles Java bytecode to native images, and it uses ahead-of-time compilation. So you kind of build the dependency graph before you start it, so the JVM can start up much faster. And since you also can compile it to native, you get the size of it down, so it's smaller and it's faster. And I put up an example here from Reddit and Quarkus, and as you see, the Quarkus REST application starts in like a couple of milliseconds, while a regular Java-based similar app would start in like 10 seconds or 4 seconds or something. And if you want to learn more about Quarkus, you should go to the session that is after this one, where Quarkus will be demoed. So how about frameworks then? Can I use Spring in my functions, for example? Yes, you can. And you can pull in any framework you want to do. But what you need to be aware of, the more dependency you drag into a function, the slower it will start. So think about this and the use case you're using functions for. If you're writing a function for a batch job that is going to run by a timer trigger during night, it doesn't matter if it takes a couple of seconds to start up, because it will run for a couple of minutes anyway. But if you want something to scale, like a voting app or something, you probably don't want to pull in too much into a function. So that was what I thought to talk about when it comes to serverless and the small implications with Java. Now I'll change and go into talk about the different FaaS implementations out there, and I'll demo a couple of them. So first of all, we have OpenFaaS, and OpenFaaS is serverless functions made simple for Docker and Kubernetes. It's an independent project, and it is a growing community being built around it. And the website and blog and everything is on openfaas.com. When I checked, it didn't support Java. That can change. That's why I put 3 dots there, because every time you write these slides, they kind of update something and you have to add stuff. So they might as well support Java now, I'm not sure. Then we have Apache OpenWhisk, which supports Java and a lot of other languages. And I'll demo Apache OpenWhisk in the context of IBM Cloud afterwards. Then, of course, you have Google Cloud Functions. They support Node.js and Python. And I don't think they support Java, or I'm not sure if they actually have any plans of supporting Java either. But Google also have is behind the initiative called Knative. And Knative is it's kind of a set of components so you can build and run serverless applications on Kubernetes. So it's Docker and Kubernetes underneath. And it offers features for scaling, for clusters and event frameworks and everything. So it's kind of cloud native applications on Kubernetes for functions. And since it's in Docker containers, you can write it in whatever language you want. And then, of course, we have AWS Lambda, which is the first one out there. And they support Java and a bunch of other languages as well. And I was thinking I should demo AWS Lambda. So I'm using sort of the same application for all the demos, and it's super simple. It is just saying hello to some name or hello world if nothing is said. So in AWS you have a dependencies for the Lambda core, the Java APIs there, and you simply just write a class that implements the request handler and has the input and output. So the request handler has a method called handle request, and here I can have the person, which is the input to the function, and I can do whatever I do. For example, use the context to get the logger and log things directly into the AWS runtime. And I can return a string, which is in this case is hello, and whoever comes in there. And this is just built using the Maven Shade plugin. So it's a super simple configuration. This is my entire POM file, and it just build a jar, and then you can upload it to AWS. And you can do that using Amazon client command line tool. Or I'll show you I'll just do it in the web console. So it creates a jar here. It's not super big, but it's let me see. Yeah, so it's about 10K. So it's not that big. But you have this Lambda core, and of course, if I dragged in here a dependency for some framework that was a couple of megabytes, then the file would be a couple of megabytes. So in Lambda, you just search up your AWS Lambda console, and you can just go click a function. I'll just take the simple one, my Duke. You can see all the runtimes they support. Probably Java 11 is coming around the corner. And I just click create the function. And you can, of course, do this with a template or the client tooling. So it should be up and running pretty fast. So there, my function is created. So now I just have to upload my code. So I choose the jar I created. Oh, it's not this one. There you go. And, there you go. And also have to give it the method signature of the function I've written. And this is a package, this is a class, and this is the method. So you see I have the package, the class, and the method. And that's all I need to do to create it. So it's up there, and if I want to test this function, I'll create a test event. I'll call it myDuke event. And if you remember, it was a person with a name, and that was the only attribute that I send into it. So it's a JSON string here, and if you look at the person, it has a name attribute. So this is how it maps. So let's put it there, and then I create my test event, and now I should be able to test my function using the Duke test event. So it executes my function, and I can see here it says hello Duke. So that's how easy it is to create this practically one line of code, and package it in a jar and upload it, and you're good to go. So the next one I'm going to demo is IBM Cloud Function, and as I said, it builds on Apache OpenWhisk. They would build some client tooling on top of OpenWhisk. You can do it natively OpenWhisk, or you can use the IBM tooling, and it supports Java, as you see. So let's go and look at this. So the IBM Duke is very similar to the Lambda Duke. But here I don't even have to implement an interface. I'm using JSON as a dependency here. So that's my only dependency. And here I also use the Maven Shape plugin to create my artifact. So it's super simple configuration. What I do here, I take in a JSON object and I return a JSON object. I just grab the name from JSON object and return, say, JSON saying that contains a greeting. So since my IBM account doesn't support functions because you have to pay for it, then I'll just do it locally. So they have this IBM Cloud scripting or client tooling. So if I do IBM Cloud FN action list, it will list all the functions I have locally. And I have a demo Duke and a Duke Java. So these are just some I created before, so I'll have something if it fails. So if I want to create a new one, I say action create. I can call it hello Java. I point to the shaded jar, which has been produced by the Maven. And then I point to the main method, which is Agile Java hello, or the main class. So the configuration is very similar to the AWS one. I just don't have to give it the method name, because here the method name is that it is a static method called main. So I create it, and when it's created, I can see that it's here. And I can also execute it. Okay. So I say invoke, and I say I want the result printed here. I'm invoking the hello Java function, and I'm sending in Duke as a parameter. So, and you see it returns greeting hello Duke, which is kind of what you expected. So it's pretty fast, it's pretty okay. Unfortunately, you do have to put your credit card up there to be able to run it in IBM Cloud. The next one I'm going to demo is Azure Functions by Microsoft. They support a variety of languages, also Java, of course. And since February, the Azure Functions is now GA for Java. So previously, it's been a early access or beta release, but now they actually support it. So they've chosen a little different path. The code is very much similar. I have a simple class, which I have a method in, but here I annotate it with some functional stuff. So I'm using the Azure Functions libraries to annotate this one. This is my function. Here I can also tell which trigger I want to use. It could be a timer trigger, HTTP trigger, or trigger by something else, or I can write my own trigger probably. I can do whatever I want. In this case, I've said it's a HTTP trigger that triggers on get and post. And here also I can use the context to, for example, get the logger and interact with the cloud platform. And I'm just getting a query string out of the request and returning, please pass a query string if there are no string there, and I'm saying hello to the string that I've passed in. And Microsoft has provided some tooling for us. You can add some functions here about your cloud accounts and subscriptions. And they have this Java library that you can use to interact with the platform. And I have this Maven plugin so you can use to build your function. So for Azure, you write Maven clean package, for example, and Azure Functions run if you want to run it locally. And you can log in using the Azure client tooling and say Azure Functions deploy, and it will deploy to your cloud account. So now here I'm running it on localhost. So if I go in here and say name is Duke, it says hello Duke. And in Azure, it looks like this. You have a function app, and if you deploy it up, you will see it here, and you can actually test it using the UI here directly. So it's pretty neat. It's I don't want to try the network here, but here I can define the function in a JSON descriptor, and I can get the URL for testing it. So this is a function I've uploaded earlier for the same function. And name is Duke. So it's pretty fast and pretty easy to integrate with. You have some Maven tooling with Microsoft. The last one I'm going to demo is FN project. And FN supports Node, Java, Go, Ruby, and Python. And FN is supported by Oracle. So I'll demo FN locally and on Oracle Cloud. So with FN, it's the function is super clean and easy. There's no libraries you have to import. It's just write your code. It's a class called hello function. It's called hello request. You can call it whatever you want. And this one it uses a configuration called a system environment variable called name if it hasn't anything in input, and it writes hello to that name. So if I want to, and what FN also has is a descriptor file where you give it the Java version you want to run and the method signature and some triggers. And in this case, I've chosen a HTTP trigger. So if I want to run this one locally, and here's kind of the paradox with serverless, because the first thing I have to do is, you can guess, start my server. So, but it starts pretty quick. So I have my server up and running. I can have a different context in FN. So here I have a one pointing to Oracle Cloud infrastructure. So I just have to point it to my local one to run the local. And then I can say FN build to build my function. Okay. So I'm feeling it won't work locally because I'm using the registry from this one, but let's try it anyway. So I have to deploy a function app and a, okay, here I'm on thin ice. Let me check my README file here. Yeah, so I have to say that it's a local one. There you go. Sorry, yeah, good. There you go. Yeah, so I'm actually uploading this to the cloud. So let's go to the cloud demo rather than the local one. So what I have in the Oracle Cloud console here is it's still in early access, so you have to kind of request it to get access, but when you do, it's pretty straightforward. You get a lot of instructions of how to do it. So I'll just log into the Functions console. And also here, they've chosen to have this kind of app concept, to have a function app, which has a couple of functions. And here I have this FN Duke, which you can see has the parameter world configured. So if I want to invoke the function, I can use the FN tooling to do that. Maybe spell it correctly. There you go. So here it starts up the function in the cloud environment and executes it. And the first time you do it, it has to spin up stuff. So this is where a Quarkus compiled or a GraalVM compiled native image would be much faster. While this one goes, we can look at other ways of invoking functions. So Oracle has provided a Java API, so you can write your own. Yeah, here it says hello world. You can write your own function caller. So you have to set some variables because the security in Oracle Cloud is that you have to have a signed request. So you cannot just do an HTTP request without, or at least I haven't figured out how to do it without or disabling the security. So you have to have a certificate that you sign your request with. So you have to set up some environment to do that. And apart from that, it's more or less just to build a function request and send it over. So it's pretty straightforward when you start looking at the code. But I'll do it in the command line. So if I now wanted to, you see here it says hello world. So if I go into the UI here and kind of delete the configuration, and I call the function again, it should now say hello to null because I don't have any parameters sent to it. So it also allows me to configure my functions using the fn tooling. So I can just say fnconfig function, give it the function Duke, and say name Duke. And if I call it again, it will say hello Duke. So it's a pretty nice tooling. fn is nice and smooth to do. Your code looks probably the simplest of the four I've called because you don't have any dependencies in here. You don't need any plugins to do it. It supports at least Java 9. I think they support Java 11 as well. And you have this fn tooling outside of it. So your Java code looks really clean and nice, and it's pretty decent to use. So to sum up, Java functions on Java is coming. All the vendors support it, and they have different approaches to it. And you may feel that we're kind of moving away from this. I write my function somewhere and I can run it everywhere, because you kind of get in a situation where you have to tie into the cloud vendor. With fn, you're kind of separated the most from it. So all the configuration is kind of outside of your code. And maybe some kind of standard way of defining it would be nice. You can also get around it by writing your function in a library and have your actual invocation of the function just where you communicate with the infrastructure and just call to that library. So you can always get around it if you want to port your functions from different vendors. And with the native compilation supported by Graal, all the memory issues and the startup issues are gone. So it starts up in milliseconds, so it's fast enough. The samples from this talk is on my GitHub, and here I've listed all the different implementations I've been showing today. And that was all I had. So I have 3 minutes over for questions. Okay, so you're asking how you can better support the functional coding style in Java, such as you have for JavaScript, for example.
No, hello. Yeah, the
Cold start. Okay, the cold start. Graal is one answer to that question. So if you can compile your code to native code, it starts in literally milliseconds. So it's just as fast as Go or JavaScript or any other runtime. If you have to load a lot of things, and then Java, as it is today, is doing a lot of things dynamically. So that will be slow if you start everything from the beginning. I think the different cloud vendors are also looking at how to keep things warm without you paying for it. That will also solve it, but that is a cost and issue. So I think the native compilation and ahead of time compilation is probably the way to go. Okay. Thank you very much for listening, and remember to go to the Quarkus talk, which is right after this one. And thank you for listening.